All right, today we're looking at systems of linear inequalities. If you haven't watched my video on linear inequalities by themselves, I highly recommend that you do that before watching this video. That's a prerequisite skill to make sure you can be successful on this. In this section, we are combining things that you already know, systems. That's where before we had two lines and we were looking for where they crossed. Okay, we're combining linear, which remember meant straight lines. And we're combining inequalities. That would be your less than, greater than. In this case, it's going to be more like what we did in the previous video where you had a line and some shading, and less like x is greater than 3 where you put that on a number line with a dot and some shading. So we're kind of wrapping all of that together into systems of linear inequalities. You are still going to see inequalities that kind of look like y equals mx plus b, our slope-intercept form. Instead, you're going to see them having one of our four inequality symbols. So something kind of like y is greater than 2x plus 5, for example. We are going to have two inequalities on the same graph, which means we're going to end up with two colors. The sign, or the symbol, is still going to tell you all the information that you need to know to be able to create your graph correctly. It's going to talk to you about the type of line and also where to shade. This information was laid out more in depth in the previous video, so if you're still unsure, make sure that you watch that video first. But just as a quick refresher, these two symbols tell you that you're going to need a dotted line. These two symbols tell you that you need to draw a solid line. Either of your less than options tell you that you're going to shade below, and either of your greater than options are going to tell you that you need to shade above your line. We are still going to graph our inequalities using the same ideas that we have for slope-intercept form, y equals mx plus b. Okay, again, brief recap. This guy is telling you where your graph crosses the x-axis. It's your y-intercept. And then our slope is going to tell us how to get to the next dot on our line. Now, this is a great section for using two different colors. It helps stop things from being so confusing. So I'm going to use two different colors here, and I'm going to label them, each of my inequalities, with those colors. That way, if I do make an error or need to look back at my work, I can tell which information went with which inequality. All right, I'm going to start with that top inequality. I am making it red, so that's going to start at +2 on that y-axis. My slope says to go up 1 and over 3. And I am going to be sure to extend my line all the way across my graph. What's going to happen is we're going to end up making 4 sections, and those sections can be hard to see if you don't make your lines long enough. So I definitely recommend making your line all the way across your graph. Now is the time where I check my symbol. Looks like based on that information, I am going to need a dotted line here. I'm going to hold off till the end for shading, and that's a personal preference. If you want to shade now, you are more than welcome to do so. I prefer to hold off just so my graph is still pretty clean looking, so it's easier for me to graph the second line first. Afterwards, I'll go ahead and color over it and make it a little harder to read. But if you'd prefer to shade now, you're more than welcome to. All right, here we're going to start at -3 for my second line. Notice that I've switched colors because I've switched inequalities. My slope says to go down 4 and over 3, so down 4 and over 1, 2, 3. We can also go up 1, 2, 3, 4 and over 1, 2, 3. All right, this inequality is going to end up with a solid line. And later we're going to shade below. Now, if we were doing regular systems of equations, this point right here, the point of intersection, would be my final answer. However, in this section, it's not. If you think back to inequalities, they actually have an infinite amount of answers. So we need a different way to represent that. We can't sit here all day writing down all of the solutions for these inequalities. So we're going to give a visual representation of those answers. This is where our shading is going to come into play. So if I look at the red inequality, I'm going below the red line. I can tell because I have less than, and less than is going to tell me below. So I should be shading in two sections of my graph anytime I shade for a particular line. So for below the red line, this section is below the red line, and again, this section over here is below the red line. All right, for my blue line, it looks like we're also shading below the blue line. So one of those sections should end up with two colors. So here's one section that's below the blue line, and then this section down here that already has red shading in it is also going to be below the blue line and get some of that blue shading. All right, let's interpret our graph a little bit. So where I have two colors ends up being the solutions to my system. Now, just because there's two colors there is enough to show you that that's where your solutions are. You do not need to label the fact that those are solutions. Everywhere where you have these other three sections, those are not solutions. These ones here where you only see red only work for the red, but they do not count as solutions to the system. Remember, systems solutions need to work for both of the inequalities or both of the equations involved. So this one would only work for the red, they would not work for the blue, making them not solutions to the system. Similar here, these are not solutions to the red inequality, they're only for the blue, so that makes them not solutions to the system, although they are solutions for the blue inequality. And of course, where there's no color, these coordinates don't work for anything. All right, looking at these inequalities, okay, here's our next set. Again, I'll label. Maybe I'll use green this time, just to mix it up a little bit, feel like Christmas. So in my red inequality, I'm starting at -3. My slopes has to go down 5 and over 2. Now that does run me off my graph a little bit, and that's okay. Ideally, you would want to use your slope in the other direction. So I would go up 5 and down, or to the left 2. And again, I'm going to keep going all the way across my graph. All right, based on my symbol, I have a dotted line. Again, if you'd like to shade now, you're welcome to. I'm going to go ahead and graph my other line first. This one's starting at +3, and my slope says to go up 1 and over 2. Or I can go down and left to maintain that same slope. This one also has a dotted line. All right, thinking about my shading, if I go to the red line, we're going to be below the red line. So that's in the top left and bottom left sections. Notice when I shade, I get kind of close to the other line, but I try not to go right over top of it. Especially if you're not using two colors, it can make your graph really hard to read or hard to tell that this is still a dotted line. All right, this one also is going to end up being below, so not only am I going to need this section here where there's already some red, I'm also going to need this very big section over here to the right. All right, can you tell where the solutions are? If you said in this bottom left corner, you are totally right. And that's because that's where the two colored section is. All right, slightly less convenient. We have two inequalities here that are not yet solved for y. That does make a difference, and you do need to solve for y first. So I'm going to use purple for this top inequality. We'll start with 2x plus y is greater than or equal to 3, and we need to get y alone. This one's not too bad. I just need to move that x to the other side. I am going to put the x in the front. That way it looks more like that y equals mx plus b that I want. And this is the actual inequality that I'm going to use to graph that line. Before I start my graphing process, I am going to solve my other inequality as well. So similar to the other one, I am going to move x first. And when I rewrite, I'm going to put that x in front of that constant term. Now, if you think back, inequalities do include an extra rule that says if I multiply or divide by a negative number on both sides, I am going to need to flip that sign. That inequality rule does still apply here. So do remember to flip your sign. If you forget to flip your sign, you're going to end up shading in the wrong sections. And that's the inequality we're actually going to use here. All right, so I'm going to go back to the purple line. Here we're going to start at positive 3. My slope says to go down 2 and over 1. Since I have a nice negative slope, I want to make sure that I also have a nice negative looking line. All right, this is going to have a nice solid line. Again, if you'd like to shade now, go for it. Again, my personal preference is to keep my graph looking a little cleaner to help prevent mistakes. All right, moving on to the other line, I'm going up 4 and over 1 after starting at negative 3, which was my y-intercept. Looks like I can fit one more in this direction as well. All right, this 2 is a nice solid line. Right, when determining shading, make sure that you look at your solved inequalities and not the original ones in case of these sign flips. That can change where your shading goes. All right, so on my purple line here, it's greater than, so we're going to be shading above that line. So in this little triangle here at the top, in this longer section over here on the right. Right, as for the red inequality, I have below, because I have less than. Below the red line is going to be this section down here in the bottom, and this big section over here on the side. Now, if you forgot to flip your sign, you might be coloring in these two sections over here, which is not great. Right, our solutions end up being over here on the side. All right, keeping in mind which line is which is helpful. Again, in case you make errors, it just helps to know which was connected to which so that you can look back and be able to correct your work. Getting a little more into detail with solutions, the other kind of questions that they can ask is determining which coordinates are solutions to the inequality. So again, keep in mind that solutions are going to be in that double shaded area, so where you need 2 colors. And they also end up on solid lines, which gets a little bit more complicated now that we're putting 2 on the same graph. Solutions are not always where the lines intersect or where they cross each other. It's all about the kinds of lines and where your double shaded area is. So let's just talk points of intersection first. As you saw up in the other examples, there are 3 ways that this can happen. You can have 2 dotted lines crossing. You can have a dotted line and a solid line crossing. So one of each. Or it could almost look like a normal system of equations where you have 2 solid lines crossing. All 3 have a point of intersection, but only one of them actually counts as a solution. Because you're looking at 2 dotted lines, this is not a solution. Here, although we do have a solid line, the other line that crosses it is a dotted line, and dotted lines are not solutions either. So that too is not a solution. The only way that the point of intersection actually works is if you have two solid lines crossing. It even gets a little bit more complicated when you have two different things crossing and all those shaded areas. So I'm going to make up a system here. And we'll do that, and we're going to put a dotted line crossing it. And we'll make this shade blue. Kind of extend that purple a little bit more there. It's easier to read. Okay, so things to keep in mind would now be the lines and how they interact with the colored areas. So if you think back to the conversation that we just had, is the point of intersection a solution here? If you said no, you'd be correct. That doesn't work. If we're thinking actual sections, these are only solutions here. These would be no, no, and no up here in this blank section. What gets confusing is when the dots that you're looking at fall on these boundary lines. All right, these 2 points out here are also not solutions. First of all, they only have one color. This one is especially not a solution because it also falls on a dotted line. Where it gets a little trickier is when you're along that double shaded area. This is where the type of line also comes into play too. This is a no. Although it's on the red line within the purple section and the two colors do exist there, it is on a dotted line. So this point is a no. However, this point over here, this would work. This is actually part of the solution. It's on a solid line. It's a boundary between the purple and the red in the red section on a purple line. So that one does count as a solution. So just be very careful about what kind of line you're looking at and where it falls on your graph. So similar to yesterday, you can look for things that are or are not solutions here as well. So if I look, say, at the point 1, 1 on this graph, 1, 1 would be a solution because it's in this double shaded area. You can kind of tell that this is the double shaded area because it turned purple between this blue and red graph. All right, if I go to -3 and +1, 2, 3, 4, although this would be a solution to whatever blue inequality created this graph, it is not part of the red. So that one is not a solution. To -5 does fall within that purple area in that double shaded region. 5, -1 is only in the red. So that makes that not a solution. -2, -1 brings into play that conversation that we just had about what happens if it falls on one of those boundary lines. Now, although we are skirting the edge of that double shaded area, we're on a dotted line, so that makes it not part of my solution. If I'm at 1, 2, that puts me at the point of intersection. Now I'm at the point of intersection between a solid line and a dotted line, which we said above here is not a solution. 0, 0 does work. It falls in that double shaded area. And if I go to 4, -1, it puts me on one of those boundaries again. I am along that double shaded area, and I'm also on a solid line, which makes this one work. All right, we have one more example. If you would like to try this example on your own, now's a great time to pause the video before we move forward. So to work through this one, if I go to the point 1, 1, okay, it's only in the blue section, so that makes that not a solution. If I go to -3, -4, I'm only in the red, also not a solution. 2, -6, very much in the double shaded area, making that our first solution to this one. If I go to -5, 1, no color there whatsoever, making that not a solution. 4, 0, on a solid line on the boundary of the double shaded area, makes that a solution. -2, -3 is our point of intersection. Now this point of intersection will work. We're right at the point of intersection where you have two solid lines crossing, so that one does indeed work. -4. -4 is on a solid line, but it's not on that double shaded area. It's really only part of the red inequality, so that one isn't going to work for us. And last but not least, 0, 0 is only in the blue section, so that makes that one not a solution.